Last week we were looking at energy and what it is. This week we're still looking at energy and trying to find out some more about it. We'll be thinking about how it can be transferred from place to place, how it's a bit like water, or in our case it's going to be some very nasty black coffee, and we'll think about how quickly we can transfer it from place to place and what that actually means. Here I have some rather nasty black coffee in a beaker. Definitely wouldn't suggest drinking this, and especially not in a lab. But I'm going to say that we can use this as an illustration for energy. Because I've got another beaker here, and if I move this coffee from this beaker to this one, I'm transferring the coffee between them, and they're different containers, but the coffee itself hasn't changed. This is similar to energy. Energy can be stored in different containers. That might be a chemical energy container, so the energy that's stored in food. Or it could be the kinetic energy container, so the energy that something has when it's moving. We can look at this in the example of the ball. I'm transferring energy from my chemical energy store to the ball's gravitational potential energy store as it raises. And then when it drops down again, that is it's transferring it again from gravitational to a kinetic energy store. But energy hasn't changed. It is merely being transferred from one container to another. We're now going to think about the concept of power. When we think of power and something being powerful, what do we think of? Well, in physics, power is a very simple idea. Power is the rate at which energy is transferred from one store to another. It is the rate of energy transfer. If we look at our beakers again, I could transfer this with a low amount of power, or a high amount of power. The power of a system, the power of an energy transfer, doesn't mean that more or less energy is transferred. All it means is that more energy per unit time, say per second, is transferred. So we could look at this as being the number of joules per second. The unit for this could be said as joules per second, the amount of energy transferred per unit time. But we have another name for it, which is named after a person who built and developed steam engines. The watt, spelt W-A-T-T. And it leads to one of the worst jokes in physics. When teaching physics, you ask a student, what is the unit of power? The answer is, yes, you're correct.